Hello, everybody, and welcome back to another visual pattern challenge. We've got a really interesting one today. Here is step 1 in our pattern. Here's step 2. Here's step 3. Here's step 4. You can see it's getting big really, really fast. Your challenge is to predict how many of these squares are going to be in step 5. If you can do that, that's hard enough. But if you can do that, can you try to predict the number in step 43? And can you write an equation that could be used to predict the number of squares in any step at all? That's the challenge today. If you'd like to take it, pause the video, give it a try. All right, so the first thing I notice about this is that these, skyscrapers seem to be getting bigger really, really quickly, and it's a little bit hard to sort out exactly what the pattern is here. I guess, I'm going to try to break this down piece by piece. And one thing I'm noticing is that there's this little bit at the top that's only one wide, and it's always the step number if we think about this as being that bit at the top. So it's always the step number. So there's that. So I'm thinking in step 5 there's going to be a bit at the top that's 5 long. Now, what's going on with the rest of these blocks? So in step 1, we don't have anything. In step 2, we have a 2 by 3 block. And then suddenly in step 3, we have 2 blocks, and one of them is 3 by 5, and one of them is 3 by 3. And then in step 4, we have 3 blocks. Okay, so I'm thinking there are going to be 4 blocks in step 5. So that's at least something. 1, 2, 3, 4. Okay. And let's see what happened to these blocks. So we have a 4 by 7, and then 4 by 5, and then a 3 by 4. Okay, so I think what I'm noticing here is that this previous block, so if we start from the top, we've got that one that's just the step number, and then this one, you just add a floor to it, add one row to it. So this comes from a 3 by 3, it goes to a 3 by 4, and the same pattern goes here, right? So you had a 3 by 5, this becomes 4 by 5, so we added one more row to it. And yeah, the same thing happened here. This was a 2 by 3, now it's a 3 by 3. And then a whole new section gets added underneath. And those sections, first they're 2 by 3, then 3 by 5, then 4 by 7. So it looks, this is the first dimension, 2, 3, 4. So this would be 5 by, and it's 3, 5, 7. So I'm guessing 9. So 5 by 9. So our bottom layer, our big bottom layer is going to be 45. And then what we need to do is take each of these layers and add a row to it. So this is 4 by 7, so this should be 5 by 7 for 35. And this should be, right now it's 4 by 5, so it should be 5 by 5, so that's 25. And this one is 3 by 4, so this should be 3 by 5 for 15. Okay, so that's what I think step 5 is going to look like. Boy, so we need to add all that up. 45 plus 35 plus 25 plus 15 plus 5. Let's see, that's 25. And let's see, 7, 10, 125. All right, so I think there are going to be 125 steps in the next, or 125 squares in the next step, in step 5. Goodness, imagine trying to count like this to step 43. That would be impossible. So let's work on an equation. And I think instead of trying to map what's going on here visually block by block and add all that together, I'm just going to look at the numbers first because maybe there's some clues we can get from the numbers. So let's go ahead and make a chart with the step number and the number of squares. So in step 1, there's just 1. In step 2, that's 8. In step 3, what have we got? 3 by 5, 15, and 9. So that looks like 27. And in step 4, okay, this is going to take a little counting here. So 4 by 7 and 4 by 5, so 25 and 28. Or sorry, 25 and or 20 and 28. So it's 48 and 12 more. That's 60 plus 4, so 64. And our fifth step, we're saying 125. Now, at this point, you might be seeing something in these numbers that jumps out to you. And that is that 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. So I think we've actually got this pattern already. We've got an equation for it. Y just equals the step number cubed. So that just jumped out at me from these numbers. If it didn't at first, there's a way to analyze this, or if there was something maybe added to these numbers so that the cubes weren't obvious, you could take the differences like we usually do. So that's 7 and then 19 and what is that, 37 and 61. And then, you don't get a constant there, so you know it's not linear, but we knew it wasn't going to be linear. You take the difference of the differences to see if it's a quadratic. So let's see, that's 12, and that would be 18, and this is 24. I think that's right. And then you don't get a constant in the difference of the differences, so it's not a quadratic. You can take the difference of the difference of the differences if you have enough step numbers. So let's see, that would be 6, and that would be 6. Aha. So we are getting a constant in the third order differences. That means it's a cubic function. So if you didn't notice those numbers right away, you could try taking those successive levels of differences, and if you get a constant at the difference of the difference of the differences, you know it's x cubed. And in this case, it is just x cubed. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and that's exactly what we see in this pattern. So our equation is y equals x cubed. And then to calculate the number in step 43, you might need a calculator. So 43 cubed, and let's see, my calculator is saying 79,507 squares in step 43. Well, how did that go for you? I mean, this is such a big pattern, but when you list the numbers, you get a pretty obvious thing. If you're thinking about cubes anyway, you get a pretty obvious clue from the numbers. Did you see that? Did that go okay for you? Did you get 125 for step 5? Let me know. Thanks, everybody.